2.2b, polynomials of higher degree. So we actually talked about this at the end of last class, accidentally. But we're going to do this. So I need to find all the zeros, and I need to graph this. I need to sketch its graph. All right, so what do we need to do? What's our first step? Let's factor out of what? We can factor out more than that. I can factor out a negative 2x squared. I'd like the negative part. I think it might be a little easier. And then what would I be left with if I factor out a negative 2x squared? X squared, and then what? Minus 1. All right, and we can keep going. What could we do now? Factor that part. So now I end up having a negative 2x squared, and then what? X plus 1 and x minus 1. And so what are my zeros? 0, 0. What else? Negative 1, 0. What else? Positive 1, 0. All right, so I have negative 1, 0. I put a little dot. All right, I have 0, 0. I put the dot. And I have 1, 0, and so I'm going to put a dot here. Now, let's talk about the end behavior. It's a negative even power. It's a negative even power. So where does this thing start? Down, right? It starts down, and where does it end? It ends down, true? And so like yesterday, we go, oh, crap. That didn't work. That didn't work. And so if we try it again, we go, I don't know. I don't know. So we actually need to talk about this term called multiplicity. And so I don't really care for the term multiplicity, but we need to know if it cuts or it bounces through. And so we talked about this. How many zeros did I actually get when I have an even power? It's 2. And so if it has a 2 or an even power, it actually bounces at that 0. So at 0, 0, it's going to bounce. All right? At negative 1, 0, what's it going to do? It's going to go through because we have it cuts through. All right? Because we have a power of 1. And then at 1, 0, it's also going to do what? It's also going to cut through. So at negative 1, it's going to cut. And then at 0, it's going to bounce. And then at 1, it's going to cut through. All right? And so if we look at it, hey, we did good. We did good. Let's do another one. So now I have 3x to the 4th minus 4x cubed. All right? And so I'm going to sketch its graph, and we need to talk about if they bounce or not, or they cut through, and all that good stuff. So what could we do? Factor out of what? X cubed. All right, so if we factor out an x cubed, what am I left with? 3x minus 4. And so at x cubed, what would be my 0? 0, 0. And so at 3x minus 4, what would be my 0? 4 thirds, comma 0, right? And so I have 0, 0, and I have 4 thirds, comma 0, and I can just make it up on my little graph. It doesn't matter. So where's my end behavior? Where does this thing start? It's a positive even power. Where's this thing start? Starts up. Where's it going to end? It's going to end up. All right. Now, what's happening at 0, 0? What's happening? Does it go through or does it bounce? It goes through. Why does it go through? Because it's an odd. At 4 thirds, is it going to go through or is it going to bounce? It's going to go through because it's a odd. It's a 1 power. All right. So we just go through just like that. All right. Now, technically, it has a little wiggle. But do I really care about that little wiggle at this point? I don't. All right. And actually, in pre-calc, I don't care about it at all. In calculus, we'll talk about it more. All right. Let's do another one. So this one I have negative 2x cubed plus 6x squared minus 9 halves x. Bless you. All right. What's wrong with this thing? You don't like something about it, and that's okay. What don't you like about this one? It's got a fraction. Daggone it. Rude. So let's take out that fraction. All right, let's take it out. All right. So instead, we're going to take out a negative 1/2. All right. not just a negative 1/2, but all of them also have an x in them. So I'm going to factor out a negative 1/2 x. And this will kind of make it a little easier for you guys. So if I take out a negative 1/2 from a negative 2, what am I left with? Left with 4. 2 divided by 1/2 is 4. All right? Because if you divide by 1/2, that's really multiplying by 2. So it's really 4 times 2. Or 2 times, oh dear goodness. 2 times 2, which is 4. All right? So then we end up with 4x, what? Squared. Good. All right? And then what? I took out a negative 1/2 from a 6. So what would that be? 12, but not, now it's a negative 12. And I already took out an x. And then if I took out a negative 1/2 x from a negative 9/2 x, I'm left with what? Positive 9. All right. Now I have this 4x squared minus 12x plus 9 thing going on. So it's a quadratic. And what do we do to quadratics? Factor them. F them up. So what's it factor to? 2x minus 3 and 2x minus 3. So I could change that to what? 2x minus 3 quantity squared. And so when I set these equal to 0, this part would give me a 0 of 0, 0. True? And then this part would give me a 0 of what? 3/2, comma 0. So if I graph that, I got 0, 0. I got 3/2 right there. But what's happening at 0, 0? What's happening at 0, 0? This one cuts. What happens at 3/2, comma 0? That one bounces. All right, because it has technically what's called an even multiplicity. I don't really care for that word, but that's really what it's called. Negative 2x cubed. Where does this thing start? Up. Where does it end? Down. Which one's it going to cut through? 0, 0. And then when it gets to 3/2, it's going to bounce. All right, so it's going to bounce back. And hey, let's see how we did. We did a great job. Look at that. All right. Pretty cool. All right, this one I'm going to talk about is called an intermediate value theorem. You're going to actually see this in the first part of your calculus days if you take calculus. All right, it has nothing to do with calculus, but it's in there. So, intermediate value theorem. I want to read her. Thanks, Juan, for volunteering. I appreciate it.
If f is continuous on the closed interval.
What does continuous mean? You can draw it without lifting your pencil. All right? You can draw without lifting your pencil. Keep going.
A and B, f of A is not equal.
What does this mean?
Not equal to.
What does that mean, though? The y values are what? Different. So they can't be at the same height. That's what it says. All right? So you can draw without lifting your pencil. The y values are not at the same height. Keep going.
And k is any number between f of A and f of B. Then there is at least one number c in A and B, A comma B, such that f of c is k.
All right. This is the way I think of this theorem. Okay? Its gang sign is IVT. You don't actually have to say intermediate value theorem. You can use your gang sign IVT. But what this means is it says if it's continuous, my two y values are different values, then there's going to be a monkey in the middle. All right, has anybody ever played that game? No? Nobody's ever played monkey in the middle? Wow, you guys have a terrible childhood. All right, so this is what it means. If you have a different y value and it's continuous, there will be at least one time that something's in between. All right? It's pretty simple, true? All right? That is intermediate value theorem. However, why doesn't this say intermediate value theorem works? Because it's not continuous. All right? And we've talked about polynomials being nice, smooth, continuous curves, true? So polynomials are going to be well behaved. All right? All right, so it says use IVT to show that this polynomial function, f of x equal to x squared plus 3x minus 2, has a what? Has a 0. What does it mean to have a 0? That's an x-intercept. So this is basically saying f of c is equal to 0. All right? It means 0 needs to be somewhere in between. And then it says on the interval 0 to 1. So what we need to do is we need to figure out if its y values are different. And how would we figure those out? We substitute in what? 0. And I'm going to substitute in 1. I need to make sure that those are different values. So if I substitute in 0 into this equation, what do I get? I get negative 2. If I substitute in 1 into that equation, what do I get? I get 2. Are those the same y value? No, those are different. I got negative 2 down here. I got 2 up here. So what do you know? 0 must be in between them. And so this is what you write. You write an inequality. So you say negative 2 is less than f of c, which is equal to 0, which is less than 2. And then you throw up your gang sign, IVT. All right? So the first thing you need to check is if your y values are different. All right? And then whatever you're solving for, make sure it's in between those two y values. You throw up your inequality, and then you're done. All right? And that's it. There you go. There you go.